What's up, guys? Welcome back to ONeill Code. Today we're going to go over the difference between a depth-first search and a breadth-first search on a graph. These are both important concepts to fully understand how graphs work, and you'll get some practice using stacks and queues. So let's look at this example graph. The objective of these two searching algorithms is to hit every vertex just one time. We do not want to look at the vertex multiple times so we can cut down the overall runtime of our algorithm. We can first start by looking at the depth-first search, or DFS. This will take advantage of a stack to track the order of where we have been and what we need to look at. We can first start at vertex 1. Since we're looking at this vertex, we need to somehow alert ourselves that we've been here. We can push onto the stack and mark it on the graph as visited. Since it's now marked as visited, we can look at the vertices that are connected. We have 2, 3, and 6. We're going to take the smallest value, which is 2, and do the same we just did with vertex 1. We're going to push onto the stack, then mark it as visited. So now on our stack, we have 2 on top and 1 on the bottom. We now check which vertex is smallest that connects to 2. Since it only has 3 and 5 that are not visited, we move on to vertex 3. We push onto the stack and mark it as visited. Now looking at the graph, there are no vertices connected to 3 that have not been visited. Since this is the case, we can pop 3 off the top of the stack. This brings us back to vertex 2. We again need to find the smallest vertex connected to 2 that has not been visited. Since 5 is the only non-visited vertex connected, we move there. We push 5 onto the stack and mark it as visited. We now need to look at vertices 4 and 6. Since 4 is smaller, we move there. We push 4 to the stack and we mark it as visited. So we look at vertex 4. Since 4 is only connected to vertex 5, which has already been visited, we can pop that off the top of the stack. This brings us back to vertex 5 since it's the new top of the stack. We look at the connected vertices and see that 6 is the only non-visited vertex left for 5. We need to move there, push 6 on top of the stack, and mark it as visited. Since 6 has no non-visited vertices, we pop that off the top of the stack. This moves us back to vertex 5. Vertex 5 does not have any non-visited vertices, so we can pop that off the top of the stack. This moves us back to vertex 2. This does not have any non-visited vertices, so we can pop that off the top of the stack as well. Now this brings us back to our starting vertex, which is 1. There are no vertices that we can hit, so we pop that off the top of the stack. This leaves us with an empty stack, and we visited every vertex in the graph. And that is how we complete DFS. If we were looking for any vertex in this graph, we would have found it because we eventually hit every vertex. Now we can move on to breadth-first search, or BFS. This algorithm is going to take advantage of a queue, unlike depth-first search, which uses a stack. If you know the difference between a stack and a queue, you can imagine the difference in these two algorithms. Since a stack is last in, first out, we always took the vertex off the top of the stack and moved back to the one below. A queue is first in, first out, which means we will take the first vertex we add to the queue and bump that out. Let's look at the graph again and walk through what this really means. We again look at vertex 1 to start. We are going to add 1 to the queue and mark it as visited. Then we're going to do the same thing we did with depth-first search in finding the next smallest vertex. Since 2 is the next smallest, we can add that to the queue and mark it as visited. But this time, instead of going to vertex 2, we are going to stay at vertex 1. We are going to keep looking at the vertices connected to it. We have 3 and 6 left. Since 3 is the smallest, we are going to move that to the queue and mark it as visited. So again, we're going to stay at 1 and look for the remaining vertices that have not been visited. Since 6 is the only one left, we move that to the queue and mark it as visited. Now all of the connected vertices to 1 are visited. We're going to remove 1 from the queue since it's the first vertex added. This is the first in, first out that queues are based around. This means we move to the new head of the queue, which is 2. We begin the process again. We look at the connected vertices and we have 1, 3, and 5. Since 5 is the only one that hasn't been visited, we add that to the queue and mark it as visited. Since there are no more non-visited vertices connected to 2, we remove her from the queue and move to the new head, which is 3. Now looking at the graph, we can see that 3 has no new vertices to look at, so we can also remove that from the queue. This moves us to vertex 6, since it's the new head of the queue. This also has no new vertices, so we can remove it from the queue and move to the new head, which is 5. Now 5 has a non-visited vertex, which is 4. So we can add that to the queue and mark it as visited. Since there are no more vertices to hit from 5, we can remove it from the queue. This leaves us to vertex 4. Since this has no vertices we can move to, we remove it from the queue. So now the queue is empty, which means we used up all the connections possible. We visited every vertex, and this completes breadth first search. Now that you have both algorithms, you may be wondering which one you should use to search the tree. Well, this completely depends on the graph you are given. If you know that the vertex you are searching for is relatively close to the root, you are going to choose breadth first search because it checks all the children before going deep into the graph. But if you know that the vertex is deep into the graph, you're going to choose depth first search because it goes further down the levels of the graph. So hopefully now you understand how to search graphs. If you liked the video, please give it a thumbs up, and if you want to see more videos from me, hit that subscribe button. Peace out.